Hello folks, let's continue with our next problem. It's problem number 16 which we are going to do, and it is put up on the board. It says that it is the integral of tan raised to 4x dx. Again, tan, as I told you, is a very alien function for us. We are not so happy to deal with tan, so every time we will be eager to convert it in terms of sec. So because sec is more accessible function for us, so let's write tan raised to 4x. Let's try to convert it as tan squared x times tan squared x dx, out of which one of the tan squared x, let's convert it in terms of sec squared x minus 1, which comes by the identity. We know that 1 plus tan squared x is sec squared x. So we are using the identity. Instead of tan squared x, we are calling it as sec squared x minus 1. So that is what we have been doing here. Now after this, let's open the integral and see how it comes. You have your first integral as tan squared x sec squared x dx, and the second integral is, when you open the bracket, it is tan squared x dx. Again, tan squared x dx is, as I told you, is not so accessible to us. So we will replace it as sec squared x minus 1 dx. And let's finally open up everything. So this comes to tan squared x sec squared x dx, and this is sec squared x dx plus integral dx. When you open up the minus into minus, it becomes plus. Now here, this is not so very comfortable. So let's make a substitution u as tan x. So when u will be tan x, you'll get the derivative du over dx as sec x tan x. Yeah, so that is making it as yeah, I hope everything is tan raised to 4. It calls for me to check once again. Yeah, tan raised to 4 is fine. We made it tan squared sec squared minus 1. Tan squared we have opened up, so it has become tan squared sec squared, tan squared, which we have written as sec squared minus 1. And the first part, it's tan squared sec squared. We are calling u as tan x, so therefore du over dx is going to be yeah, tan is sec squared. I'm very sorry, tan is sec squared. So you are going to get sec squared dx. That's it. So this part alone, with the help of this, we'll take it all over again, but then only this part let's solve. So this will come to the u is tan squared, so u squared, because it is tan squared. U is tan, so u squared, and sec squared x is du. Like that, this can become u cube over 3 plus c actually when we write. So let's get the integral all over there. The I, let's look at the I. Now the I is, as we got it, u cube over 3 after we do the integral. Sec squared x is tan x, and integral of dx is x plus c. So when we revert back, the u for us is tan x. So tan cube x over 3 minus tan x plus x plus c. So that's how our integral is working out. That's it. So we can now go to the 17th problem, which says that I is the integral of sine cube plus cos cube. Yeah, we are into sine cube plus cos cube. Sine cube x plus cos cube x over sine squared x cos squared x dx. To begin with, let's separate and see what happens. So it is sine cube over sine squared cos squared dx, and this is cos cube over sine squared cos squared dx. So you can have the power 2 can cancel, and one sine will be left. So you are left with sine x and cos squared x. Here you are left with 1 cos and sine squared x in the denominator. So this is like cos times cos. So sine over cos can make it tan, and 1 over cos can make it sec. So also here This is sine times sine. So 1 cos and sine can make it cot, and over sine can make it cosec. Like that, when we revert back, the integral of tan x sec x we all know is sec x, and the integral of cot x cosec x is we all know is cosec x. So minus cosec x plus c. That's all. That's for our problem number 17. Let's quickly move to the problem number 18, see what it says. Problem number 18 is cos 2x. That's another simple question. Cos 2x plus 2 sine squared x over cos squared x. Okay, cos 2x, we all know there is a formula for cos 2x which says that it is cos squared x minus sine squared x. So let's make that substitution. Cos squared x minus sine squared x instead of cos 2x, and you already have the 2 sine squared x already there over cos squared x dx. These many things are there. So cos squared x will stay as it is, minus sine squared x plus 2 sine squared x will make it sine squared x. So it will be plus sine squared x over cos squared x dx. Now sine squared x plus cos squared x is 1 because of the identity. So we are left with 1 over cos squared x dx. That is sec squared x for us. Integral of sec squared x. And we all know that integral of sec squared x is tan x. So that's all for this problem. It's quite simple. The next is a bit complicated. Otherwise, we could have clubbed it over here and do. It may take time. So that we can take it up in the next video. So that's all for today's work. These are the problems that we did here. As I always tell, please popularize the channel, spread a word, and see that we are there everywhere. Thank you.